Thank you, Dr. Rijit. And I can see Dr. Harish Karnatak also, and all the participants who has come to attend this very interesting course, which is organized by Indian Institute of Remote Sensing, mainly, to apprise our school teachers about the India's space program and its applications. First and foremost, my greetings to each one of you, and I'm sure that you all must be enjoying this particular course since all of you are in the field of teaching, and you are the curator of the future of our young generation. The idea is that it is important to you all to know about India's space journey and how the space activities which are being done by Indian Space Research Organization are being utilized for the purpose of benefit of common man. Okay, so what I will do that in next 40 minutes or so, I will try to talk mainly on the uses of these remote sensing technologies and how these different kind of sensors are helping different sectors and also helping the common man of India to take benefit from space technology. Abhijit, can you confirm, are you able to see the slides?
Yes, sir. The slides are visible.
So, I understand that already some lectures have already been given to you in which some basics of space technology, basics of remote sensing technology, and the basics about different orbits, the type of electromagnetic spectrum we use, all this has been covered. So I will not repeat that. What we will try to emphasize more that how we are using these technologies for various sectors in this country. And that is what this lecture will be all about. So if we talk about the requirement of our country as a whole, and we are aspiring to become a developed country in next 20-25 years or so, we have to face certain challenges in terms of our resources. So let us review that. What are those challenges? So India, as you know, it's the seventh largest country with only 2.4% of land area, and we are hosting largest population of the world. In fact, today itself, the news has come that our population is around 1.46 billion, which is highest in the world. But commensurate to that, our land area is only 2.4% of available land area of the world. So this is a big dichotomy here as far as resource availability is concerned. Then, we have a agrarian economy where large amount of people, more than 55% of India's population is still dependent on agriculture in direct and indirect way. We have around 142 million hectare net sown area, 0.12 hectare per capita land, which is fairly small compared to international standard. We get around 110 centimeter of average rainfall. Our coastline has now been, enhanced to around 11,000 kilometers, which has been recomputed. In this slide, you are seeing 7,500, but now it has been revised, and it basically is around or approximately 11,000 kilometers. We have 21% of our total, geographical area, and which is covered by forest. And the country is bestowed with 12 major rivers, including, various tributaries and, streams within these river basins. Now, currently, as I told, we are around 1.46 billion people. In terms of economy, our economy is doing fairly well. We are now fifth or fourth largest economy of the world. But the major challenge is that our economy is still service dependent. 60% of economy is service dependent, and 15% of production is coming by agriculture practices. Industrial growth is only 25%, which for a developed country is a smaller number compared to what you see in case of Europe or in case of America, where you know the developed country status has already been achieved. So now, if we have to scale up to that advantage or to that position in another 20 to 25 years, we will face a lot of challenges. Our population will rise to around 1.7 billion, and 50% of people will move from, they will live in urban areas. There is still migration happening, and it is likely to continue also. Our food grain requirement will also enhance by 2030, and our groundwater, which is basically being used for agriculture as well as for drinking water purpose, it is also depleting rapidly because we are doing over exploitation of groundwater. And this is expected that water scarcity is likely to enhance in India if we don't take right decisions right now. There is another threat, which is basically known as climate change. Many of you must have heard casual remarks that every year, the temperatures are rising because climate is changing. This year also, the heat records are getting broken up. Last 2 3 days, you all must be experiencing. You are all in Dehradun, I think. Even in Delhi, NCR, and all these areas, temperatures are crossing 44, 43, 44 degrees Celsius, and heat every year is becoming much warmer than previous years. And this is typically explained by the rise of temperature, which is already around 1.5 degrees Celsius, but we expect that in another 20 years or so, it can rise up to 1.7 degree also on an average on a global basis, which will lead to sea level rise also. So large amount of coastal cities and towns, they may be underwater. And then disasters, the frequency and intensity of disasters is also increasing. Every year, large amount of destruction is happening because of heavy rainfall event, extreme weather event, lightning events are also on rise, which basically leads not only to the mortality of human beings and the livestock, but also large amount of damage to infrastructure, which in a changing climate is expected to grow. So, if we have to deal with these challenges and still continue to develop with 7 to 8% growth rate, we need to do certain things, on a priority basis. So, what is required to be done is that we have to think of enhancing our agriculture production. We have to adopt smarter agriculture practices. We have to reduce the water intake in our agriculture crops. India uses large amount of water, and most amount of this water is basically not required as far as crop productivity is concerned. So there is a lot of wastage is happening as far as use of water is concerned. Somewhere some optimization has to happen. We have to minimize land degradation. Large amount of our land is under biological degradation because of various factors, including large amount of use of fertilizers as well as pesticides. So that also we have to think that how we can start arresting this land degradation. And we have to conserve bioresources, essentially our forests, which are very important from the environmental standpoint, as well as keeping the carbon cycling intact for a very healthy ecosystem. We need to think of conserving this while still growing with a 7 to 8% growth rate. Now, weather is a very important phenomena today, and today, even though we have made significant advances in weather forecasting, but still a lot of things are required to be done where precise weather forecasting can help people to avoid disaster situation. If you are going out on a tourism, you must have very accurate weather information that if any adverse weather is likely to happen in next 24 hours or in next 12 hours, you can think of taking a appropriate decision, including postponement of your visit if you are likely to encounter very extreme weather, so that the inconveniences can be avoided. Weather forecast is also very important for agriculture sector, maritime sector, logistics. For any sphere of life, this becomes very important. Then we have to, as I was telling, that these disasters which are increasing every year. Last year we have seen, disasters like landslide in Kerala, then a lake bursting in Sikkim in 23. then extreme, flood events in northeastern India, and then intense rainfall, and in Vijayawada in Andhra Pradesh, large amount of forest uprooting has happened in Telangana. Many of you must have experienced similar things in hill areas also. There are a lot of landslides which are happening. So we have to do development which is disaster resilient. That means it should be able to withstand some of these disasters. That type of planning is required to be done. Then this climate change issue, which is basically there due to the enhanced emission of carbon dioxide into atmosphere, because our over dependence on hydrocarbon based economy is leading to enhanced emissions of the carbon dioxide and methane in the atmosphere. In in the year 1950 or so, the average carbon dioxide concentration in atmosphere was roughly around 350 ppm, parts per million. Today, we are making continuous observations here at National Remote Sensing Center, and the ambient carbon dioxide concentration is around 425 parts per million. So there is a significant amount of increase in the carbon dioxide concentration in our air, which is leading to what we call as greenhouse gas effect. And if we have to, curtail this and keep the climate in control, we have to adopt for clean and green energy sources. India has already made commitments that by 2070 India should achieve a net zero emission policy. That means for generating our energies as well as for your day-to-day mobility and other sectors where energy requirements are there, most of it will come from clean and green energy sources. This will also lead to reduction of water and air pollution. So that is most important aspect. So for that, what is required? We have to go towards alternate source of energy like solar energy, wind energy, as well as geothermal energy, and then also do large amount of recycling of these energy sources. Even biomass, which lot of crops are produced in India, which produces large amount of residues, this also can be converted in the form of bioenergy, and it can be utilized as a alternative source of energy when compared to the hydrocarbon based like your petrol diesel based and coal based economy. Then, of course, connectivity is also very important for growth today. Without internet connectivity, life is not is unthinkable, and we need to, as the data communication requirements grows in future, we have to also think of uh, considering satellite based internet connectivity, which can provide you high throughput compared to the terrestrial networks which we are working today. So all these aspects are very important, but nothing is possible, none of this can be achieved if we don't have peace and security around us. You must have seen the recent developments in our neighborhood where that peace and the security was destabilized because of certain unwanted situations. So we need to keep our borders secure, not only our land borders on both western and eastern sectors, but as I told you, we have around 11,000 kilometer long coastline. We have to also worry about securing our maritime zone. That means our naval system also has to be very important. And for all these things, you need to build what we call as geointelligence. You need to know what kind of things are being done by your adversaries, and you have to keep an eye for them. So for all these aspects, you need to collect a lot of data. And today, without having data, decision making is next to impossible. And lot of data is collected by ground-based systems, but majority of data sets for generating what we call as the sustainable development is today dependent on space sector, or satellites are providing a lot of information to us. Without even your knowledge, you get lot of information on food, water, energy security, health security, and I will discuss some of those examples as we move in this particular presentation. So this particular domain of space activity is known as Earth observation. We are not going to talk today on satellite communication and satellite navigation. We will be mainly focusing that how we are observing our own planet Earth, and we are using different part of electromagnetic spectrum. We are using different type of satellite systems with having varying capabilities to derive information about various components of our planet Earth. So using today we have built constellations. I understand there was a lecture on satellite technology by director of URS Satellite Center. He has given you the basic fundamentals of satellite building for Earth observation, satellite communication, and satellite navigation. So going in detail of that, today we have Earth observation systems which provide a lot of valuable information about our atmosphere, which includes you know measurement of ozone layer, includes measurement of greenhouse gases, includes any kind of water vapor which is present in the atmosphere, cloud formation, etc., which is very important for understanding our weather and climate. We have satellite systems which can give information about bioresources like forest cover, deforestation, loss of various kind of forest species, agriculture, kind of crops which we are going, and also to an extent that the kind of habitats which are basically very important for wildlife, that also can be monitored using certain kind of satellite systems. We have large resources of water on our planet. In fact, 70% of our planet is ocean. So it's a water planet, and we have around 2 to 3% of fresh water which is stored on continents, either in the form of snow, precipitation, as well as in the form of glacial ice, which basically becomes the source of fresh water for all our requirements. So we get a lot of information about snow cover, snow depth, as well as the status of glaciers on our planet. And of course, we derive lot amount of information about oceans using these satellites, because oceans are very vast. They cover 70% of geographical area. People don't live there. Collecting data about oceans are very difficult. So satellite gives you large amount of information about the state of ocean, both the physical part as well as the biological component of the ocean, which are very important for fisheries, for navigation, as well as transportation across different regions of oceans. Then, of course, we can get information about from land dynamics, what kind of land use, land cover changes are happening, what is happening to our inland reservoirs, how the soil erosion is happening, and then, of course, about the biodiversity losses also. Satellite data can help you finding out, solutions to some of these pertinent problems. So all this, put together are basically, has been defined by United Nations as sustainable development. And to achieve this sustainable development by 2030 or so, 17 sustainable development goals have been identified. No poverty, zero hunger, and many such things are there. In each spheres, satellite technology is playing a very important role for providing very accurate and realistic data sets for informed decision making. Now, when it comes to India's, present satellite capabilities, I think some of it must have already been spoken. If it is repetitive, let me repeat it for the sake of continuity. Today, India as a country, you see, we are fourth or fifth largest spacefaring nation in the world after USA, Russia, European Space Agency, Chinese, Japanese, and India is also one among them. So we are operating currently around 55 to 56 satellite systems, in which there are around 25 Earth observation satellites are there, which are also known as remote sensing satellites. There are certain satellites which are in civilian domain, mainly provide information for civilian users. There are a lot of satellites which are there in strategic domains. When I say strategic domains, essentially it means that they are meant for our defense forces. Then we have around 18 communication satellites which are providing satellite communication services as well as high throughput internet connectivity in remote areas. Then navigation or position service like GPS, we have an equivalent of that which is known as Navig, where we have a regional constellation of around 8 satellites. And then, of course, we also have satellites for space science and space exploration. I think this also must have been talked to you about Chandrayaan 1, Chandrayaan 2, Astrosat, Aditya missions, and things like that. But today, in this talk, we will mainly focus about these Earth observation satellite systems. Now, we have developed since 1988 what we call as India's Earth Observation Program. When we say program, it's not that sometime we have launched something and then afterwards we have not provided continuity. It's a dedicated program for national development. That is what is the, when I say program, it means that. So this has various segments or various constituents. We have a dedicated space segment, which essentially include number of satellites. As I told you, around 25 satellites. Out of that, few are in civilian domain, which provides information on land and water. This provides information for high resolution mapping. Also, information about terrain, then ocean weather and climate. Then launching a satellite from a rocket itself is not important. Once satellite goes into space, it keeps on revolving and it basically do certain functions. And that function includes collecting data about the Earth's surface in different part of electromagnetic spectrum. Now, once this data is collected by some sensors which are there on board satellites, this data needs to be brought back to the Earth itself. And that is where the role of ground segment comes. So in a ground segment, you have to have a data acquisition system. There are a lot of antenna systems, ground stations we have built. So using these antennas where the satellites which collect data is transmitted through microwave energy. It is modulated on a microwave carrier frequency, and then it is received by our ground station. It has to be demodulated, and then it has to be processed at different levels to convert into an image which I am showing over here, like a radar image or a multispectral image. So this process is called basically ground segment operation. So we have to convert, after processing this data into data products. There can be different levels of data products. We have to validate some of these data products with some in situ observation networks. And then you have to also provide this information to the users. Users can be in different ministries, they can be in states, they can be private sector users, they can be private individual users also. So for that, today we have a lot of dissemination systems. Essentially, most of the dissemination is in digital form today, and it is done through our websites and web portals, which has been generated by various ISRO entities. So here in NRSC, we provide all this satellite data today to everyone in the country as well as outside country through a web portal called Bhunidhi, and I will be talking about it later on. So once this data is available in the hand of the users, they have to use it for some purpose. And that is where the domain of space applications comes. So this data sets has to be converted into some information, and out of this information, some knowledge needs to be derived. So various applications, I will talk about it in subsequent slides. Then we have to also develop the linkages with different users. People, all of them are not well versed with space technology. They need to understand that what information they are getting, or they have to also harness this data for effectively utilizing in their day-to-day decision making. So we do a lot of institutional linkage with ministries, with departments, with the 29 states which we have in this country through their remote sensing centers. India has also opened up the space sector for private industry. So large amount of private sector startup companies are also coming up. They also wants to do a lot of businesses and build businesses around these space-based data sets. So we knew a lot of hand-holding and technological transfers to this industry, and large amount of academic institutions like our IITs, NITs, various engineering colleges, Their students do a lot of research using this data for various, ecosystems. So that also we do a lot of hand holding with them. In today's world, doing everything single-handedly is not possible. We have a lot of international cooperation. We do cooperate with friendly countries like Americas, Europe, even Japan, and many other things, and France, Germany, and we build, collaborative programs with that. So all these four verticals, which I just talked about, space segment, ground segment, applications, and institution linkage and capacity building, is part of overall Earth observation program of India. So it's, as I told earlier, it's not important that one time we have sent some couple of satellites. So we started sending this Earth observation satellite in 1988. Since then, we are ensuring that we provide continuity to this operational applications. That means when one satellite, it lives its own life around 5 years or so, we need to replenish that resource in space. We need to do planning to find out or to build new satellite systems. And then we have to also enhance these capabilities with over period of time depending on the needs of the people. And then we have to also do periodic assessment of natural resources. Like every 2 years in India, we are making assessment of forest cover and forest degradation as well as forest losses. We are also doing every 15 days assessment of water resources. How many, water bodies are there? How much water is available in our dams and reservoirs? And then we have to also develop forecast models also to provide information for our stakeholders. We have been doing a lot of early warnings for disaster like flood forecasting. We are doing, we have developed advanced models for that. And then of course provide a lot of information to decision makers as well as citizens for giving these services. So these all becomes part of India's Earth observation program. Now I told you that we have some number of Earth observation satellites. So the details of those satellites are available. Don't worry too much about these names. But typically we have four thematic series. One is called Natural Resource Inventory and Disaster Management, Large Scale Satellite Mapping and Infrastructure Planning, as well as Oceanographic series of satellite systems, and then Weather and Climate series of satellite system. So lot of different variety of satellite data comes by these type of constellations. And I'm not going to go into too much of technical details because sometimes it can be too much information. But what I am interested to tell you that how this data is being used in different domains. Before we talk about applications, there is another very important thing one need to understand, that once a satellite is orbiting over Earth, we have to do planning of collecting this data. We have to receive this data through a ground segment. We have to have a real-time data acquisition system in terms of developing in hardware, converting them to suitable formats, and then only this type of data is ready for archival. We have a big data center here in NRSC, around 40 petabytes of data we can store. We have around 35 years of satellite data over India as an archive. So any historical changes, let's say around your city, if some changes have happened, you can track those by studying the old imageries and compare them with the recent data sets. And then, of course, disseminate this data to various users. So this complete framework for space technology based applications has been built in India over a period of time. And India is one of the leading country in terms of adopting space technology applications today. And now a lot of industries partnership is also gaining traction, which is leading to a lot of commercialization and monetization of these data sets. So as far as the use of these satellite data is concerned, in different sectors today, satellite data is being used. We'll see some case studies in agriculture, in climate and environment, defense and security, energy, extractive industries where a lot of minerals and mines, mining is done. Then, of course, in terms of banking support, also, a lot of banks are using satellite data in terms of knowing the capabilities of their customers to repay their loans. So, banking and finance is also becoming a big customer of these data sets. healthcare, medicine, pharmaceuticals. There are certain plants which are having, pharmaceutical capabilities. Transportation sector, a lot of mobility sector for, tracking their live locations, as well as, road network alignment, etc. Satellite remote sensing data is being used. Illicit activities, a lot of illicit crops are grown in this country, like poppy, and then marijuana and many other, things are also there. So we keep a track on those things so that, illicit activities because of this type of crops can be avoided. Tourism, we, provide a lot of information to tourists about various natural locations. Logistic companies are using this data in a big way. And of course, telecom and science and research and technology. There are different sectors in which today satellite based technologies, and in particular remote sensing technologies, are being used. This is how the high resolution satellite imagery looks like, which is acquired by the satellites which are operating at around 500 kilometers. So some of you can immediately recognize this is over Delhi. This is our old parliament building, the round shape, the famous classical old parliament with a central dome. And then now this new parliament has also come up here, which is of triangular in shape. And then you can see this, what is known as Kartabya Patharjan, where the road leads to the Rashtrapati Bhavan. This is Rashtrapati Bhavan here, and many other buildings like North Block and South Block, from where a lot of, major activities or the country is being run, from these buildings today. And of course, the resolution is so high that you can even see the cars which are there on these roads. This is another example of, one of the satellites high resolution imagery called Cartosat 3, where, you know, we get data in what we call as the panchromatic mode, or, black and white picture, which is of course at around 30 centimeters or so. And then we get, images in multispectral or in different wavelengths, and we can combine this high resolution panchromatic data and multispectral data to come to convert into a colored image, which you can see over here, you know and this becomes around 30 centimeter color data by doing some kind of a mathematical, analysis. So now what you see a lot of details. You see a chimney, you see road networks, you see a canal through which the water is coming to this cooling tower of some plant. And all these red things what you see are essentially the forest or the plantations around this power plant. So it is also important to develop an understanding to interpret these images. These are some chimneys or stacks in a thermal power plant where coal is burnt and then power is produced. So like that, one needs to develop an understanding of interpreting these images over a period of time. This is a this was an example of a local phenomena, a very high resolution images, but we also capture Earth in relatively coarser resolutions, where coverage becomes more important. So this is a global coverage picture which has been covered by one of the India satellite, which basically meant for ocean observation. So this is an ocean sat image where all these red regions are essentially rich in vegetation. This is Amazon forest. All these white regions are basically snow covered areas. You can see Himalayas. The Himalaya is a very large, mountain range which covers around more than 3,000 kilometers, and it is abode of snow and glaciers. So you can see this white reflected, feature, which is essentially nothing but, snow covered peaks of Himalayan mountains. Then, of course, all these dark oceans, and then Antarctica region here in the southern part of the our globe. So this data is collected at 1 kilometer spatial resolution, while the previous one was collected at around 30 centimeters. So when you have very high resolution data, details are more, but area becomes limited. But in case of, coarser resolution data, the details are less, but coverage becomes very high. So this is a dichotomy of, observing systems from space. What examples I showed you are essentially in the visible and infrared part of electromagnetic spectrum. But one big problem is that you get a lot of, data get lost, like this clouds or thin haze, which is there most of the time, especially during monsoon period. particularly over India. Now, if I have to do image, that means when clouds are there, I cannot see the Earth's surface. But there may be requirement during war time or strategic time, or even for resource mapping like rice crop mapping, etc., which happens in Kharif season, to see the Earth's surface through these clouds. Now, to see through clouds, we have to go and rely on another technology. Not visible infrared part of electromagnetic spectrum is not sufficient. We have to go to a longer wavelength region of electromagnetic spectrum, and then we choose a wavelength region which is known as typically microwave region, which is the wavelength region is from few centimeters to meter scale. Okay, so this is one example of one of such microwave image which can see through cloud, and we have developed this type of sensors which are typically known as radars. And this is a image captured by India's own imaging radar called RISAT, Radar Imaging Satellite 1A, which is basically a repeat of previously launched satellite. So through this type of radar satellites also, lot of observations when clouds are present are made. This type of data is very important for flood mapping. Whenever flood happens, like this is the season of floods, there are a lot of floods are happening in northeast region, but clouds are there. But if you have to map how much area is under flood, then this type of radar data becomes very important. And I will show some examples of radar-based flood mapping to you also. These photos which I showed you, they were like two-dimensional photos. But from satellites, we can also get the third dimension of the Earth. Third dimension means like hills and valleys. If you are sitting in Dehradun, you must be seeing, in far distant areas, the hills of Mussoorie, which is around 2,000 meter, mean sea level height. So that kind of topographic variations also we can capture using satellites, and we have launched a satellite system called cartographic satellite, Cartosat 1. Using that satellite, we have created now topographic information of entire India. So whatever you see in white color is the high mountainous regions. This green color is the plains of India. Then you see these Vindhyans, they are relatively elevated features. This is Aravalli range of mountains. And then this is Deccan Plateau over here. You can see Bangalore slightly located on a high elevated area. And then, of course, the coastal plains of Tamil Nadu, and Andhra Pradesh, and Orissa. And then, of course, the mountain systems of Northeast, including the hill system, the Garo, Khasi, and Jaintia hills of Meghalaya also are very nicely captured in this topographic map, which has been captured from satellites. Apart from that, we also have aircrafts and UAVs, which also provide you very high resolution topographic data. This topographic data can be combined with these two-dimensional data sets, and then you can create, what is known as the digital twins of these features. So what I'm showing you is one of the digital twin created in lab by our colleagues there in IIRS itself, where now we are flying over Gangotri Glacier. This is Gomukh, from where the Ganga originates, and now we are flying over this Gomukh or the Gangotri Glacier, and this is how a glacier looks like. Some of you, if you have not gone to these glaciers, in lab itself, in this class itself, you can visualize how a glacier looks like. And from this glacier only, river Ganga originates. And if you go to the higher reaches of this glacier, you can see this bright snow. And then the downward part is relatively having lesser albedo. So you can basically construct the topographic information. You can see the slopes of these ridges so high. So all this information today sitting in your laboratory on your computer itself can be converted. So this doesn't give you only a good picture. It also tells you a slope. If you have to put a road here, you can find out proper alignments for the road. If you have to put a telecommunication tower, you can use this slope information to find precise locations for telecommunication towers. So this data becomes very useful for multiple applications for different uses. Now, there is no point in keeping data, all this data. As I told you, we have around like 35 years of old archive data with us. And every day here at National Remote Sensing Center, at our ground stations, we are receiving almost 1 terabyte of satellite data. Now, this data needs to go to the user, and that's what I told you. We have now a complete online digital mechanism to transfer or to provide this data to the users through our this web portal called Bhunidhi, and all kind of Earth observation satellite data are provided to users from this particular web portal. You can download sitting in Dehradun itself today's images. Maybe some of my colleagues can demonstrate also to you. Now, having received this data, you have to use it for certain purpose, as I was telling earlier. So there are a lot of applications are built like water security, energy, food, infrastructure, and essentially to achieve the goals of sustainable development. We will go one by one. So let us see that how this data is used for agriculture sectors. Okay, so agriculture, as I told you, 55% of India population is involved in agriculture. We are the second largest producer of food grain as well as horticulture fruits in the world. So large amount of activity in the agriculture sector happens in this country. It is very difficult to monitor also. So using these satellite images where we can get pictures of the ground over a period of time with repeated frequency, we are now using this data to find out agriculture drought situation. We are basically using it for crop mapping, how much area is there under one crop, different type of crops like fiber crops or high value crops, which area is growing what type of crops. Certain regions in your area, you must have seen that some land parcels are never utilized. So we identify such fallow parcels and then we do what is called as crop intensification. Then lot of crop damage happens because of the adverse weather, etc. And now there are schemes in India which basically are crop insurance schemes supported also by government of India. But how to give that crop insurance money? How to determine whether crop failure happened, not happened? You need some proofs. Even if your car get damaged, your insurance agent will ask for some proofs. So now how to give proof that crop is damaged or not? So that comes from satellite data. We are having a Just Tech program across country where large amount of satellite based crop insurance, settlements are happening. Crop yields are also calculated using satellite data today. After the harvest of crop, large amount of residue remains in farms today. Many of you must have seen during the Kharif season, pollution is a big problem in Delhi or in NCR or in North India. Suddenly in October, November, December, a lot of pollution happens. Some of that is also basically happening because this residue or that parali which is left in field is being burnt by farmers. So can we convert this parali instead of burning? Can it be collected and can it be converted into biodiesel? So for that we have generated what is known as from which area how much such residue is available. In this blue region you can see this Punjab, Haryana, UP. It produces lot of this parali. Then states like Rajasthan, where not much of cropping is there, Palari is not there. So, but Rajasthan has a lot of, livestock. इनके पास जानवर बहुत होते हैं और जानवरों को चारा चाहिए होता है. तो can this parali which is being burnt can go to Rajasthan? All those kind of decisions and activities can be converted if we have data on parali itself. So this is the data which we have generated about the parali. एंड देन देयर लोकेशन कौन सी जगह में किस डिस्ट्रिक्ट में किस गांव में कितना पराली पैदा हो रहा है. So that is where this information becomes very useful for managing the agriculture waste also. So we are supporting a lot of government of India scheme like Pradhan Mantri Krishi Sinchai Yojana, Pradhan Mantri Krishi Bima Yojana, Ministry of Renewable Energy for this biodiesel related aspects. So lot of such kind of applications are being supported today using satellite data. So here in Maharashtra, we are showing you how the sown progress is there in different areas, what kind of drought conditions are there, whether enough soil moisture is there or not there, which areas mango orchards are there in which district, because fruits are also very important, where coconuts are there, where areca nuts are there, supari is there. So like that, a total information system has been built about the crops in India. This is a very interesting, photo where you see that in Kharif in 2024, how the Kharif progression in whole country were there. So by June or fourth week, this yellow area is already sown. Then July second week, 130, lakh hectare area. July third week, 228 lakh. So you can see this blue yellow area increasing continuously. So by the end of second and third week of August, entire country kharif crops are grown. So this is the advantage of these images, that our planners can know that how the kharif sowing progression is happening. Then based on this, we can also estimate that how much area is under rice. So we have done a very detailed mapping by utilizing thousands of satellite images to convert them into a rice crop map. So all these yellow regions, are the rice crop map. So maximum rice is grown where? You can see. So maximum rice which you are eating is grown in Punjab. It is grown in Haryana. But around your Dehradun, Roorkee and all, you have a lot of sugar cane. So you don't grow rice there. Here in this part of UP and then eastern UP in Bundelkhand, in Bihar, in Chhattisgarh, then this is Chhattisgarh, then in Bengal, Orissa, and Telangana, and then some part of Kaveri Mahanadi Delta here and Kaveri Delta in Tamil Nadu. These are the hotspots and pockets of rice growth, and some floodplains of Assam also. So this is a real map of crop growth or rice growth in India. What you see is in green color is the permanent forest. So these are the forest region. In forest region anyway, no much activity is not allowed. So all the agriculture growth is happening in these pockets from where rice is coming to your table. So that is a very important information. To get this information or by ground means it will take more than 4 or 5 months of patwari, information. Many times these patwari fellows, वो सही से they don't even properly record information. वो अपना घर में बैठ के लिख देता है, इसका खेत में इतना पैदा हुआ, ये क्रॉप लगा है. So lot of fraud information can be avoided when we have this satellite based estimates of crop production. So this is one such example where satellite data is very effectively being used and transparently being used for providing information about crop area. We can convert into crop yield also. So here one example in Maharashtra where taluka level crop yields have been estimated, and wherever the crop yields are failing or reducing, like all these red talukas, these are the districts where crop insurance compensations has to be given to the farmer, because compared to the average yields, their yields are very low, and then these farmers becomes eligible for claiming crop insurance benefits from the insurance companies. So based on this satellite data today, lot of crop insurance, claims are being settled. There is a full-fledged, protocol and a system under Yes Tech program of Ministry of Agriculture and Farmers Welfare, which is implemented in many states of the country where NRSC, SAC, ISRO, and other ISRO entities are providing a lot of support. This is about agriculture. Then not only India's rice we can map, we can also map, use our satellites, they see all over the world. So this is one example over Vietnam. We have done, rice mapping of Vietnam. There is a famous river, it's called Mekong River. And this Mekong River Delta is famous for rice crop. These are full photograph of rice crop. Thousands of hectare area is only rice, rice, rice. So Vietnam grows, huge amount of rice in this Mekong Delta. So we are also able to keep eye कि भाई हमारा पड़ोसी लोग कहाँ कहाँ पर क्या क्या उनका एग्रीकल्चर हो रहा है, किस डिस्ट्रिक्ट में, क्या प्रोविंस में, what kind of agriculture practices are happening. That also is possible using this. So you can do some kind of jasusi in your neighborhood also using this type of satellite data. तो खाना तो हो गया, agriculture is one such example. So today, not only I showed example of rice, for more than 11 crops, we are providing in-season assessment of various kind of crop acreage, crop, yield estimations, which is supporting government of India. Then water. Water is another important aspect. A lot of fight happens for water. पानी की लड़ाई बहुत है. So on a national level or on a district level or even at village level today, we are able to provide lot of information about water availability. आपका reservoirs में how much water is available, how much water is available for irrigation, canals do have water or not, then how much water evaporates because a lot of water goes into air. आपका पानी उड़ जाता है, आप खेत में flood irrigation करते हैं, but only very small fraction of that water is used for is used by the soil. Rest of the water goes into atmosphere. So we are able to calculate that also. We are also keeping an eye in Himalayan systems, Himalayan glaciers, etc., etc. So water informatics is very useful, and a lot of data from satellites are provided on the water information. So this is a water meter or a water dashboard which we have generated with one reservoir called Krishna Raj Sagar Reservoir in Karnataka, and this is the major reservoir which provides water to Bangalore city. Now in 2022, Bangalore faced a huge water crisis. पानी नहीं था, लोग people were taking bath while going to hotels and all those things. There was no water. So as you could see from August to February, the water in this reservoir reduced by 50%. From 10,000 hectares, it became only 5,000 hectares. So 50% water was lost because rains have failed in that year. And water availability in the major reservoir was very low. And that led to, a lot of water crisis in a big city like Bangalore. So this information now we are putting on websites of ISRO, and this data is being used by a lot of water managers for regulating, alternate sources of water if water is not there in the reservoir itself. So for entire country, every 15 days, we are providing this surface water spread for entire country from NRSC under National Hydrology Program. Similarly, this Himalaya, as I told you, it is basically a board of snow and water. Three major North Indian rivers, Brahmaputra, Ganga, and Indus, they originate from Himalaya. So how much water? All these rivers, they get water because of the melting of snow and melting of glaciers. So we keep an eye how much snow is there in different months, how this snow is melting, and once the snow will melt, how much water will be available. We can do what is known as hydrological modeling in these river systems. And this data becomes very important for lot of dams. There are a lot of small dams, big dams are there, which produces electricity. Hydropower plants are there. These fellows wants to know कि भैया हमारे रिजर्वायर में कितना पानी आएगा, so that we can plan our electricity grid regulations with this kind of data. So we are providing operational assessment of snow water equivalent and snow water melt runoff in different river basins in entire Himalaya. Then another threat because of the climate change is that large amount of glacial lakes, more than 28,000 of lakes have formed on the mouths of these glaciers. And many of these lakes are expanding very fast because of the climate change. Here you can see one lake which is expanding very rapidly in Nepal region. So now we have done, entire mapping of these lakes. So around 28,000 lakes have been found, which are having area of 0.25 meter hectare and above. And some of these lakes are basically, they're very vulnerable. They are rapidly increasing. One such lake was South Lonak Lake in Sikkim, where the lake, area has increased by 3 times in 30 years. You can see this was very small. Now it has become very big. And then suddenly one fine day, some, a lot of snow avalanche happened. And then you can see on October 23rd, half of the glacial lake has been filled by snow and debris. And this much water, it basically got spilled out of the lake, which created a flash flood down in Tista River, and more than 200 people died. So we did a complete analysis what happened on that day, and then we have mapped the flow path. We have also mapped the changes in the river morphology and provided accurate information about such processes to Government of India. And then now we are keeping, there is an early warning system which is being developed for 190 such lakes across 9 Himalayan states using space technology as well as some ground-based observation system. Water in states like Rajasthan is a big issue. You don't get water for drinking. The bore wells don't work, they fail. Bore well depth can be as high as 200 meters, 200 feet or something like that. So we have to find some areas. These areas are called paleo channels, where old riverine systems were there, but now they are under sand. So using satellite data, we can find these old paleo channels, and then if we do some geophysical survey, we can pinpoint and then find very high potential water sources, even deserts also. रेगिस्तान में भी हम पानी खोज सकते हैं using this satellite technology and some ground based methods. So using this type of applications in Bikaner, in some Upani village, we have provided lot of support to villagers where groundwater resources were discovered successfully, and many such places this work is being replicated. I talked about energy, clean and green energy. So using this solar panels, nowadays India has done very well, and we aims to generate 500 gigawatts by 2030. And we have already set up around 57 solar parks. So using satellite data, we can map the solar ingredients, and this is the hot spot. So countries like, states like Gujarat, Madhya Pradesh, Telangana, Maharashtra, there is a lot of solar energy potential is there, and bioenergy potential, as I have told you. So we are providing this information to people, those who are now putting solar rooftop plants and things like that. We have developed some mobile apps also where you can calculate how much solar energy you are likely to get. This is using machine learning, all the installed capability of solar plants in India today, and the progress of solar plant. This is Badla Solar Park, 2,200 megawatt plants, 56 square kilometer area is under solar park. So like that, many such solar parks. One is now developing in Gujarat also by Adani. So such kind of energy initiatives are taking place where you can monitor these things. Disaster is one another area like flood, cyclone. We are providing a lot of information through our disaster support systems. Like this is a flood map in Punjab in 23. Flood came, and then normally Punjab is not flooded, but that year there was a lot of rain, and this kind of flood maps are produced, and we provide these flood maps to a lot of district administrators like collectors, etc., so that relief rescue can be planned. We have another kind of satellites around 36,000 kilometers from Earth. These are all called meteorological satellites. They can track the cloud movement. So here you can see a cyclone is being tracked. And by using this type of data today, we are in a position to tell 5 days in advance about a cyclone. And the cyclone forecasting capability of India is one of the best in the world. 5 days in advance, we can tell with a precision of around 20 kilometers that which place cyclone is likely to strike. And then we can evacuate people from that area so that loss to the life can be minimized. Of course, you cannot minimize the damage to infrastructure, but at least people's life can be saved. So we have another satellite called scatterometer, ocean sat-3 scatterometer, which 5 days in advance provides information where cyclone starts developing. This process is called cyclogenesis. So using this data also, lot of information comes about cyclones. Then oceans, as I told you, they are very important for various, economic development. We are also keeping eye throughout our coastline. We are providing information on potential fish zones, coastal zone management, aquaculture. Many such activities are happening. And this is an image from our satellite where productive part of the ocean, all these areas like green in color is highly productive. A lot of fishes are available in these areas. In blue regions, there is no biological productivity. Phytoplankton productivity is minimal. So these areas are known as deserts of ocean. So on land itself, you have deserts, you must have heard, but I am showing you there are deserts in the ocean also where no fish, nothing grows, no biological growth happens in these blue regions. Only it gets confined to this green and red regions. So we map such areas and then provide this information to fishermen on a regular basis so that they can avoid, going unnecessary places, and with minimal effort, their fish catch enhances. So this service is an operational service by Ministry of Earth Sciences, and this is called Potential Fish Zone Forecast Service. And today, all in these maritime states of the country, this information every day morning is provided, and more than 10 lakh fishermen are getting benefited by this service. So we not only provide this data to common man, to government, this is provided through some kind of web-based actionable product and services. So we have developed a lot of web portals like Vedas, Bhuvan, Endem, Mosdac for various purposes. And I'm sure that there must have been a plan in this session to expose you to some of these web portals so that you yourself can spot exploiting some of this geospatial technology. And once you go back, at least you can train to some of the students to take advantage of mapping neighborhood and things like that. As I was talking about that space program, we have a space program, which means that we have to ensure continuity. So I talked about presently available satellites, but in times to come, we are going to augment those satellites with this new series of satellites like Resource at 3. We want to map the entire topography of the country again. We did it in 2005 to 2010 time frame. We want to put now new high resolution satellites, a new OceanSat series of satellites. We are also working with the NASA and the French space agencies to develop advanced satellite system. One such satellite system called NASA and ISRO synthetic aperture radar is likely to get launched next month in July. This is a very expensive satellite, 12,000 crores has been spent. So this will provide a lot of information about various features like earthquake, landslides also. So this is in nutshell the overall utilization of all our assets. Of course, for weather service also, we are planning an advanced series of satellites called fourth generation imager, so that we can continue to get in future also lot of information about clouds, properties, weather patterns over the Indian part of the continent. So with this word, I would like to close here just by reminding you that we are extensively using in this country today the satellite technology, but it is like the use of this technology is likely to grow in various sectors like supply chain, any material coming to your home. We are working on a new concept called DigiPin, where instead of pin code, you will be having a digital pin. Where very soon it is going to be launched. Defense, in Operation Sindoor, lot of information about targets and lot of information about damage through satellites, evidences, proofs we have provided. Then media, entertainment, sports, state-sponsored civil investments. A lot of information about banking and finance is coming today using satellite observations. And of course, a lot of people are getting now jobs in space sector because it has been opened up for private sector participation. More than 300 startup companies have started working in the field of space. A lot of young people are getting jobs in this area because it's a new deep tech, startup culture, which is likely to grow in India. And with the participation of young people, it is likely that India's space economy, which is around currently 2 to 3% of global contribution, is likely to increase to 8 to 10% in next 5 years or so. So we are basically touching a lot of lives from space. It's not only launching and hardware, but using this hardware for practical uses. I try to demonstrate you or I try to talk about it, but a lot of things are yet to be done. We have to reach to the last mile, so that the poorest of poor in this country can take benefit of space technology. With this word, I would like to thank each one of you for your patience, and I'm sure that you must have got some vital knowledge out of this, you will be able to enlighten your students once you go back to your work. Thank you very much for your kind attention.